Okay, I'm going to try to graph number 3. The only problem is the equations are in the other video, but let's see if I can get through this. Okay, now, so for graphing this, we had made some equations, and I'll write the ones that I'm trying to graph when I'm graphing them. If you had noticed, they said that x had to be non-negative. The old number, remember, old members were x and new members were y. So if x was non-negative, that means all my x values had to be positive, okay? And if y is non-negative, that means all my y values are positive. So all I'm looking at is quadrant 1 here. That part is telling me all I'm looking at is quadrant 1. And when I think about graphing this, I'm going to graph these lines and do all the shading that we did in section 4.10. But when I get done and I see the shaded area, not everything in the shaded area is going to be a solution because we don't have half of people, do we? We don't want to cut anybody into pieces. So we're going to have just look at whole numbers, which would be the grids in quadrant 1 on the graph. So x greater than 0 means it's above the x-axis. Y greater than 0 means it's to the right of the y-axis, and if you look at where those intersect already, we're already just limiting ourselves to quadrant 1. Let me see. It might be good. Well, we'll try. We'll try it with just the size graph. All right. So now I had the club has at most 9 old members and at most 8 new members that can work. So the old members, I think we had an equation that has to be x is less than or equal to 9. Okay. And then the new members at most 8, y has to be less than or equal to 8, okay? So right now I can go ahead and kind of mark that off. If x is less than or equal to 9, that means that right now I'm limited between these two values for my x. I'm not even going to extend it down into the other quadrants. I'm just going to work in quadrant 1. And so it's between those two. I could put shading, but this thing's going to have so much shading on in the end. You might want to shade in a light color matte pencil, but if I use a color here, we're going to get real busy really quickly. And then on the y greater than or less than or equal to 8, remember it has to be positive because you can't have negative people. So y less than or equal to 8 means now we're restricting further our graph into what's inside this little box that I've drawn with the green and the black lines. So the department will hire at least 6 students, but no more than 15. And if you remember what we had done with that, let me pick a different color just to work with that. If you add them together, it has to be 6 at least, but no bigger than 15. Okay. So when I add these together, they can't add up to more than 6. They have to add up to more than 6 and no less than 15. I'm going to save that part for later because that's going to get kind of confusing. Actually, no, I will go ahead and do this. If you think about this, let's split this into 2 parts. X plus y is greater than or equal to 6. If you notice, all I'm doing is making sure the small end of the inequality is still pointing at the 6. If I subtract x from each side, I'll get y is greater than or equal to negative x plus 6. Okay, so let's go graph that in blue. We're going to have lots of colors. It's going to be a very colorful, busy graph. If it's bigger, if y is greater or equal to x plus 6, my y-intercept would be 6, and my slope is negative 1. So down 1 to the right 1, down 1 to the right 1, down 1. I'm having trouble counting on here because it's not marking where I'm putting my finger. Down 1 to the right 1, down 1 to the right 1. I wish it would pick up where I'm putting my finger. Down 1 to the right 1, down 1 to the right 1. Okay, so it's bigger than that. So now I know it's above this blue line. Okay, so let me go ahead and shade that with those little marks here. I'm going to try to use very little shading because this is a very busy graph. But at the same time, remember now we had another condition. X plus y had to be less than or equal to 15. I'm going to come over here and work just because I've got to do all this on a graph and it's hard to fit it on the iPad. X plus y less than or equal to 15. Okay, if I subtract x from both sides, I get y is less than or equal to negative x plus 15, which means I have a y-intercept of 15, and my graph doesn't even go that high. and I have a slope of -1. So here's what I can do. Let's plug in some points to graph. Let's say if x is 5, let's pick a couple of points. If x is 5, -5 plus 15 would be 10. There's a point I can graph, 5, 10. That would be right here. And let's try another number. I'm going to pick 7. -7, plugging in 7 for x, -7 plus 15 would be 8, okay? So I'd have the point 7, 8. And 7, 8 would be on that green line right there. So if I draw this line in, and it's solid, I got to make sure it's, if I look at the slope, I could go down 2, right 2, and get to another point. So let me go down 2, right 2. That would put it here. I'm looking at this line right here, and of course I missed it because, you know, it's hard to figure out where my iPad's going to take. I almost had to. It's there, but it's less than that line, so I'm shading below it. Okay, this is getting to be very busy. If you look at where all this, you know, remember we were in between the green lines, in between the black lines, and now we've got some shading that's overlapping, and it's where I see the red and the blue overlapping. Okay, but we're not done yet because they give us, they really went overboard on some of these here. There must be at least 3 new members. Y was a new member, so Y has to be greater than or equal to 3. So that's a horizontal line through 3. So let me draw that in there, and it's the solid line. I don't really need to go any further because I know I'm between the 2 black lines and the green lines. Y greater than or equal to means now I could go all the way up with it, but I'm just going to limit, again, what I draw. I could go all the way to the top of the graph, but I'm just trying to make sure I don't make it too busy so we can actually see our answer when we get it. All right, one more thing. The number of new members, which is Y, must be at least, so it needs to be greater than or equal to a half of the old members at a half of X, but less than 3 times, so Y is less than or equal to 3 times the number of old members. Remember, old members was X, so we had Y less than or equal to 3X. Okay? So I got the Y greater than or equal to 3. Let me pick some other colors to graph. I'm going to pick a pale green here just because it's different. And I'm going to graph this one in pale green. A half X means my Y-intercept is missing. It's 0, right? So let's go put it here. And it's up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And again, you're probably only doing this because it's hard for me to graph accurately here. I mean, it's not even the points aren't going where I want them to. So there's a line there, and it's a solid line. And I'm supposed to shade above it. So let me do that. I could go all the way and fill the whole graph up, but what I'm doing is I'm trying to stay between those green lines just so I have a less busy graph again, okay? And now I got one more. I'll pick some exotic peach here or something to graph in. Y is less than or equal to 3X. Well, remember my Y-intercept was 0 here because it's missing, so I'm just going to put plus 0. That means that Y-intercept 0, so I'll go graph it. And my slope is 3, which would be up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. And it's, again, up 3 to the right 1. Kind of hard to get it to go where I want it to, but when I graph it, here's what I get. And I want less than or equal to, so it's going to be shading all the way down to that green line. I'm going to stop at the green line again. Okay, now, that's all the equations. Where's our answer here? It's almost too hard to see, isn't it? Let's find it and let's shade in yellow because that would be helpful. Let me do a pale yellow. Okay. Where I knew at first I was restricted to where the red and the blue were overlapping, so that kind of helped me break it down. Now I'm looking for where I see red, blue, purple, green, and peach. Oh my goodness, this is a fun one, isn't it? Especially trying to do it this way. So the red and the blue only overlap kind of in the middle of between this line here and this line here is where they're overlapping. And then I see peach and green. I hope I can do this correctly. It's just so busy. It's almost like I'm not sure quite why they made it this busy. Most things don't have this many restraints on them. They just went a little overboard with it. It looks to me like if I start coloring in, I think I see all colors in here. I know I can't go past that green line. and it looks to me like peach is a boundary, and then this light green is going to be a boundary, so it picks up here. So it's almost like there it's going. It would go along this line. This is going to be a border here, and then a border here. If I shade this in, it's right here. Okay. Now I'm going to kind of do this because I still got to be able to look at some points inside of there. Usually I would say, hey, that's my solution area, but we can't have half a people or 0.1 of a person lying around. We might get arrested for that. So our answers, I'm going to mark them in a black now just so they'll stand out. Anything that's a whole number dot in that area would work. For instance, right here is a solution. X is 4, Y is 4. It means I could have 4 new people and 4 old people. There's the solution, okay? Also, I shaded right in here at 5, 4. So 5, remember X was the old members and Y was the new members. So maybe if I write that down, that'll help me. If I have the 0.45, I could have 4, that's in there, 4 old members, 5 new members. And it looks like it keeps going right here at, let's see, I'm sorry, I got off on that. 4 or 5 is in there. But so is 5, 5, 6, 5. So solutions, it would be like list of the whole number points that are contained in there. If I go and I dot everything that's colored in yellow here, you know, anything on that line would be a solution. I'm trying to make dots and it's coming across not as dots. Right here would be a solution at that intersection right there. Right here. Right here, all these points along this top line here that are on whole number graphs. I could read off each one of those points, and again, this would be easier if you're using matte pencil so that you could see through them. But anything that's on a whole number grid here is going to be solution. So like I see that I've got the 0.36. I could have 3 old members and 6 new members. Anything that's on a grid line there would be my solution. So you could take something that's complicated and see what your possibilities were. There aren't that many of them if you just count up all the hash marks that are shaded in where that light yellow is. Any of those whole number points that are in there would be my solution. So I could list all those out and see my possibilities. Fun times, huh?